All right, rate of change. Everyone's popular slope. Change in y over the change in x. Um, Delta y over delta x. Different ways to refer to the rate of change. I'm going to calculate the average rate of change of a function over a specified interval and interpret the average rate of change of a function over a specified interval, and then to solve problems involving direct variation. And we're going to learn what direct variation is if you do not remember it from algebra. Okay, so direct variation, what we're talking about here is the relationship. It's a quotient of the dependent and independent variables that remain constant. So direct variation can be written as y equals kx. And in this formula, you recognize your y and your x. K, that is going to be my constant of variation. How are they varying? And it's constant, so it's going to look like a straight line. Something to remember too, that direct variation passes through the origin of the coordinate plane. But my constant of variation, the value of the quotient, right, of the dependent and independent variables, or the product of the dependent and independent variables. Well, we have a quotient and a product. Why do we have that? Well, for direct variation, this would be a product. Okay, y equals kx, because that's being multiplied. But if I were to solve for my constant of variation, which is going to be k, I would isolate that by dividing both sides by x. And that would be k is now equal to y over x. So that is a quotient of my dependent and independent variables. So that's how you can see multiplication and division. And so as we talk about this, we're going to talk about the difference between the rate of change and slope. The rate of change is the ratio of the change in the independent variable in respect to the dependent variable in respect to the independent variable. So if we think about the old coordinate plane, not a very good coordinate plane, rushed, but it's going to be this. As my x changes, my y value changes. So that is a ratio. And it's the ratio of my rise, my change in y over my change in x. The ratio, that little fraction of as I go up over as I go right to left, up or down, right to left. And then the rate, that rate of change is called its slope. And if you remember, the old slope formula was the y2 minus y1 over x2 minus x1, which happens to be the change from one y value to the next over the change from one x value to the next. Okay, so as we talk about direct variation again, there's my direct variation in a function or in a multiplication. And it does go through the origin, because if you'll notice, my y equals, think of it in a line, y equals mx plus b, slope-intercept form. Here, b is 0, there's no b, so that means it's going through the origin because I haven't moved right, left, up, or down. So that's why I say that it moves through the origin. And the direct variation, well, k cannot be 0, because if k is 0, then this is equal to 0, which then would not be a change in y, change in x. And the constant, the k value is always going to be, it will be constant for any values on the ordered pair, or on the coordinate plane. So remember that y equals kx, or k equals yx. So now it says, what is the relation? What relation is a direct variation that contains the ordered pair of 2, 7? What relation is a direct variation? So they're asking me to come up with, thinking about my direct variation, I have y equals kx. Where's my relation? Well, what I have three variables here. I have y, k, and x. I need to solve for k. They've given me my x and my y, but if I'm looking at it and just say, well, there's one variable that I haven't solved for yet, so let's go ahead and do that. So I'm going to replace my x value, x with my x value, my y with my y value, so then that would be 7 is equal to k times 2. And now let's just go ahead and isolate that as a quotient. So I'm going to divide both sides by 2, and k is going to be equal to 7 halves. So now the relationship that contains that ordered pair, well, I'm going to replace k now back into my original direct variation. So it's going to be y is going to be equal to 7 halves x, and that should be my direct variation. All right, so that's what they were asking for. Now we could go back, and we're going to do that here in this next one, to find a point of variation at any value of given x or y. But looking at this next example, it says if y varies directly as x. Okay, varies directly. When you hear that, varies directly, they're talking about direct variation. So we're going to use direct variation when it varies directly. So let's look at y is going to be equal to kx. And then y is equal to 18 when x is 5. What is the value of y when x is 11? Well, the variation is constant. So let's go ahead and do our constant variation, and we're going to solve, make it easy on us, we're going to solve for k. And we're going to use the first two values of x and y that they gave us, because that will help us solve for k. So if I substitute in 18 for y and 5 for x, I get 18 is going to be equal to k5. And k being that constant of variation, I'm going to go ahead and isolate it. And then my constant of variation, which is k, is equal to 18 over 5. And if I rewrite that in my relationship, I get y is equal to 18 over 5 times x. Let's see here. And what is the value of y when x is 11? Well, guess what? They want you to know what y is when x is going to be equal to 11. So I just take it, plug these values back in here, and y is going to be equal to 18 over 5 times 11. And we could multiply that out. Goodness. We'll just leave it as that. Y is equal to that. Because it asks what is the value of y. There you have it. Y is 18 over 5 times 11. And that is working with direct variation. And then it says the average rate of change. Now, direct variation is that constant rate of change, but now we have something that is not a straight line, so my slope doesn't stay constant. And they want to know what is the average rate of change. Well, what we're going to do here for this is we're going to have the average rate of change is going to be the rate of change over 2 points. And they said from the interval of 2, 9. So let's see here, 2, right? There's the start of my interval, and then right here is going to be, so we want to find these 2 points, this point, and I'm not sure which other point here is the best to use. Okay, so as I think here, this is going to be my f of x and x, so my average rate of change is written as, again, the change in y over the change in x between the values. So remember, my slope is y2 minus y1 over x2 minus x1. Well, I'm looking here as my new expression would be, instead of y, I'm going to use f of, okay, f of x minus f of x over x2 minus x1. And so I end up with something along the lines of, right here I have f of 9, because that was my given interval, right? F of 9 minus f of 2 over 9 minus 2. And that would be an expression to calculate the average rate of change of a function. Because I'm just thinking that I draw a line right there, and I basically calculated the slope of that line that I just drew, because it would be the average between those 2 points. Okay, as I look at the average rate of change, looking at this function, if I'm trying to find out what is the average rate of change, the average rate of change, okay, for this function, we'll call it f of x, average rate of in f of x over the interval of 4, 13. Okay, so the interval of 4, 13 is going to begin here and end here. So if I think about the average rate of change, I need to know my y and my x values. So my x values are going to be, of course, 4 and 13, and then my output, my y value, is going to be 8 and, 8 and 11. So again, if I'm trying to figure that one out, 4 and 8 is going to be my ordered pair, and then 13 and 11 is my ordered pair here. Now remember that this is going to be my x and y, so I can set that up as a ratio. My average rate of change is going to be f of x2 minus f of x1 over x2 minus x1. So my output here on this, we'll just call this x2 y1, or I'm sorry, y2. So the output of x2 is going to be 11, and then the output of f of x, the first spot, is going to be 8 over the input of the spot minus the input of the other. So we end up with possibly the wrong information here. Yeah, because I made a little mistake here. No, I didn't make a mistake. So if I figure these one out, so I end up with 3, 11 minus 8 is 3, over 13 minus 4 is 9, which is going to be 1/3. So the average rate of change over the interval of 4, 13 is going to be 1/3. Because as I go up 1, I go up 1, I go over 3, and that would be my average rate of change between those 2 points. So again, change in y over the change in x, y2 minus y1 over x2 minus x1, as we talk about our rate of change.